Hi, my name is Taylor Leach, and this is my Physics 2211 Lab 1. The goals of this lab were to compare an observed object with a constant velocity to a model of that object um, that is acting in the same conditions with the same initial force. And the goal is to determine the differences between the observed object and the model object. So, in order to make these observations, we need to first know about Newton's law. Newton's first law states that an object in motion will stay in motion unless it is acted upon by an outside force. This is important because we see in the observation and the model that um, the differences in motion between the two can be contributed to an outside force uh, that would be occurring in the observation. That would not be in the model, as the model shows the movement with zero forces acting on the ball. Newton's second law is also important. Um, and Newton's second law is given as F net equals the change in momentum over the change in time. Using this formula, we can see that if F net equals zero, then the change in momentum will equal zero, as momentum is equal to um, velocity and mass. And that means that the change in velocity will also be equal to zero. So our observations, our real world experiment, we rolled a soccer ball across a wooden floor and saw that using this application called Tracker, we were able to graph the position of the ball and the x and y coordinates. And as you can see, the movement in the x direction is not exactly constant. And as you can also see, it does get uh, less and less steep as it moves on. Our model was done through a computer program on GlowScript using the formulas, the velocity update formula and the position update formula. And from this model, we saw that the position versus time graph had a constant slope that was positive and not increasing. Constant, I guess I already said that. But you can see that the velocity stays the same. It does not change, and it is constant, which makes sense as Newton's law states that velocity will remain constant unless the object is acted upon by an outside force. So, to discuss how results would change if the axes were different, this would change the direction of the ball, the initial position of the ball, as the initial position was not exactly 0, 0, 0 in our observation or in our model. And the final position would change as the ball would be traveling in the opposite direction. The slope of the position versus time graph would become negative, and with that, the velocity would also become negative. Now, in answering how many forces added up to the net zero, we don't exactly know this in the real world experiment because there are many forces such as friction and air resistance that could have acted on the ball, which could have varied the movement. But in the simulation, we know that there were zero forces acting on the ball after it initially started moving. So we know that zero forces were factored in. In conclusion, we learned that a net force of 0 will lead to constant velocity in the motion of an object, and that there is a slight difference between the model and the observation that can be contributed to varying forces that were not incorporated in the observation, as the model was done in a perfect vacuum, while the observation was done in the real world, which has various other